Kind of a lot going on in this one, huh? So, first of all, what are we trying to figure out? Okay. Yep, the measure of that bottom triangle type thing. Good. So WTX is that angle right there. Okay, well, what's a good way to do this?
Well, I just put x plus 93 where theta is.
Okay.
Just to move it up. I don't really know if that matters, but.
Oh, it does matter because these are all angles and this is not. So it does matter that you know that these are equivalent, right? That's important. Why are they equivalent? Asking to everybody.
Because all angles in a circle add up to 360?
Well, that's true, but that's not what I'm asking. I'm saying, why can I copy x plus 93 to theta?
Because like the side length and the angles are the same?
No. Side length is not the same as side what?
Measure.
Measure, yeah. So let's use arc. I'm bringing that up because that's kind of what we ended on yesterday, so it's a good transition back into that. So this is arc measure, right? And that is equivalent to, let's actually use this symbol. Remember that one? What does that little guy mean? You guys remember? Equals with the tilde means congruent. What does congruent mean? Same with a little bit more to it. Same measure, same size, all that. Anyway, it equals that central angle, or is congruent to the central angle. Okay, go ahead.
So when you say arc measure, are you talking about like the example that you always show us like with the scissors? Like how long and wide it is to build the angle?
Yeah, I guess so. I guess in this case, like these lines would be the scissors. The difference there is I have in the past just used like a piece of wood, not something round. But however far we open that angle to cut is the same as the measure or the degree measure of the arc that it opens through. So if you think about opening scissors, it's not going to be easy to see. But do you see how the tips, so just look just at the tips, are going down?
Yeah.
So it's doing this. Right? So it's making the arc. It's invisible, but as you open them, it's the arc that they followed. If we could maybe if we had dirt and we could open it through in the sand and it would make a little half circle or something, right? Does that make sense? So that's a good way to relate it, actually. Thank you for bringing that up. All right, anyway, so now we can copy that to there. That was just a little review of why. Now what? You were saying what you did.
Oh, I added everything together and equaled it to 360.
Good. Yep, so all of these, whether they were all out here as arc measures or central angles, they all add up to 360. So it's kind of a long line of stuff, but that's okay. Minus 6 plus 65 plus, actually let's just go minus 8x minus 2 plus x plus 93 plus x plus 84 equals 360. Alright, because when you have something like this, there's lots of ways to mess up, isn't there? Because there's just a lot going on. So let's combine all our x's. So we have negative x, another negative x, so that's negative 16, and then 2 x's, so negative 14x. And then let's combine all these. So negative 6 and 65 is 59. And then negative 2 makes 57. And then 7 plus that 3 makes, what did I just say? Yes, it's, okay, so 60, and then 9 is 150. And then 84 is 234. I got a new tip. Might have some issues. Let's try it again. Everybody good on that step? Did I just double check? Did I get the 234 good? Okay. Anyway, from here it's just normal. So subtract 234. And we're going to get a negative x. I asked you this yesterday, but is that okay? Yeah, if what? Right, as long as it doesn't make any of those negative or arc measures, either one, then it's okay. Anyway, so 60, 60, and 6, so is this 126, I think?
Mm-hmm.
Right, and then what's that division? When you divide by negative 14. Negative 9. Okay, there you go. So how'd that go for you? Okay. All right, quick review. Why don't you grab your pink packet, and let's go review what we wrote right at the end about arc length. Oh, you know what? Sorry, before you do that, pause. Let's go check the rest of that sheet from yesterday. So pull it out. We'll check the back since we left it. Since this is all the same as all the same content as our warm-up. So number 10, it's kind of like the one we just did in terms of workload. It's kind of a long equation that you have to filter through, but you end up getting 105 for angle VST, 105 degrees. Any questions on that one? Okay. Number 11. Now I'm going to tell you to take note of this one because this is a common looking test problem for this class. Okay? Where I give you a single picture and ask you, in this case, what is that, 10 different questions? Okay, there's one that we probably will do later on. It's one picture with 32 different questions. So it's a good thing to get used to seeing. And while I'm talking, hopefully you're checking. You got it? Okay, good. Was that long enough? Can I scroll down? Okay. Alright, number 12, kind of similar situation. Multiple answers for one picture. How's it going on this one? Okay. Anybody want to volunteer to read this? In fact, let me just emphasize what I'm talking about. Just to make sure we're all tracking with given directions. Anybody want to read that in English? Like translate from math to just regular speaking. Savannah, thank you. She didn't actually, but I'm going to see if she did.
Triangle, measure
Okay, good. You're on the right track. Do it again.
Measure of angles equals
Perfect. Yeah, good. All right. How did the back page go? Okay. Overall, so if you're still struggling, let me know, or come talk to me rather. We can get you some more practice. But that stuff was up to this red line. So minor arcs, major arcs, solving for those, and then arc measure, central angle, that kind of stuff. We switched yesterday at the end to arc length. And length is something you can put a string on and see the length of it, right? The actual inches or centimeters. And remember we had a weird letter, which was S for it. What did this part tell us? This theta over 360, that whole piece.
Isn't it like the fraction of the angle in the whole circle?
Yeah. In other words, if you think about like starting here, here. Well, how much of this, think about reading a clock. We went halfway around 180 degrees, that would obviously be half of the length of the arc, of the whole thing, the whole circumference. Okay, so if we went like 112, since that's what I wrote, 112 degrees, that's 112 out of the total 360 fraction of the circle. That's what we said yesterday. So that's the formula. And pi times diameter, again, could be written as what else? If you didn't want to use that version. Ooh, close. That's area. Pi times radius times 2, yeah. So I suppose we could add that, or 2 times pi. For some reason, not for some reason, this is normal to write it this way, but you'll mostly see it as 2 pi radius. It's really just 2 radiuses times pi, which is the same, okay? But usually you put the 2 and then the pi and then the r. Like normal, we put the variable at the end. Okay. So let's go use that and show you a couple problems with it. Our goal today is practice this a little and then also to do the area of a sector, which is very similar concept. The equation will look a lot like that one. Okay, before we do that, everybody pause and look at this. This is your warm-up problem. Kind of get it in your head. And then here's a different, completely different kind of problem. But do you see how similar they look? What is the only difference that tells you to do the problem differently? That word right there. Well, that word and the fact that there's no little m out front, right? So it's subtle. You got to read and pay attention when you do this. Why don't you try this one? Length of AD. Length, not measure, but length. So again, it's length, but even still, we do need the measure of angle APD so that we know what fraction of the whole circumference that little length is. So we are trying to find that length right there. And to do that, we need angle APD. How do we get angle APD? Yeah, good. So 360 minus these other 3. What was it? 140?
Yeah.
Somebody's saying no. 130?
I know.
Okay, so it's kind of. So let's just check and make sure. So 360 minus 73, that's not it. 73 minus 43, and 104. Everybody ready? Do you see what you did?
Yeah.
Alright, so angle APD tells us what? Like, why did we need that? Well, true. I mean, we do now know all of those angles. But why did we care about angle APD?
That angle is still on top of 0, 60.
Yeah, good. Because it's telling us, like, I can't really show this on the screen, but if I use the pen, it's telling us the amount of the circle that sweeps through and covers on the circumference, right? So now we can say S equals 140 out of 360 times pi. And what's our diameter in this case?
8.
Times 8. Okay. I need to fix that. I hope this doesn't continue. It looks like it might. I don't know if it's my computer or this.
Maybe.
Because sometimes when my computer gets laggy, it does the same thing. Right. It's a little better. It's ready to take a break, I think. 140 divided by 360. 360.
You quick
I
subtract.
Okay.
I think you might have to put it on the computer.
I'm gonna have to get the old one. Sorry, that's too bad.
Maybe it needs more weight.
Okay, there we go. Times. I'm gonna use the pi button, which might make my answer a little different than yours.
What's that?
So I got 9.77. And 4 didn't have any units, so just put units on there. Anyway, point is there, like, if we just work through the problem, it's pretty fast, right? If we didn't have the pen issues and stuff. But the big idea is not confusing how far this is around, far meaning length, not confusing that with how many degrees it was, right, the measure. So just read carefully. How'd that go for you? Seem okay? All right. Why don't you try a couple more? Let's try to get you a good one. Maybe that one. I'll zoom it just a little bit.
Thank you.
And give you a minute. Okay. So we need the measure of angle YRZ. Here's what Bailey said. So add all the angles to 360. Okay. Then what? Just solve. What'd you get?
I got x equals 89.
Everybody good on that? Okay. And we needed that Y. Yeah, we're looking for this arc. We only had 47, so we needed the rest of it. Here's how I would write this. I would probably just put in the formula, just the sum in there, out of 360. But you don't have to. Just like you don't have to use parentheses around the pi times diameter. And in this case, what is the diameter? 18. Good. Okay. And if you're careful with plugging this in, you can do it this way on your calculator. which means you do need parentheses around that, like this. And then otherwise it's fine. Again, I'm using the pi button. That's not what it is. Pi, there we go. And times 18. And we get 21. Let's round to 0.4. How'd that one go? Okay, based on what I'm seeing, you guys are saying that arc length is doing fine, right? Even if you have to manipulate to get the angle and do some things before that. We're good on that? Okay. So in a similar, you'll get more practice with it, but just to make sure it's good for now. In a similar strategy, we're going to find the area of just a piece of the circle. Okay? And the formula will look pretty similar to that. And that area is called a sector, that highlighted kind of yellow area. So this is the pizza slice now, right? Or the piece of pie. So I said it's in a similar method to the arc length. So if we say area of a sector, what do you think is going to be in that formula? I bet you could probably come up with it if I told you like area of a sector. I bet you could tell me what to put right there. So think about the components that went into finding the length of the crust of that piece. Now we're just doing the pizza slice, the area, like how much cheese do we need to put on there? What do you think has got to be in there? Hmm? Okay, she said radius, yeah. Okay.
Pi times radius.
That's close.
Pi times diameter.
No, that's circumference. Now we're finding the fraction of the area. So we've got to have the area in here for sure, which is what formula? You don't know, look. It's on your first page, like box 3 or so. Yeah. Okay, but what goes here to tell us it's just that piece and not the whole thing? Because right now it's just saying the whole area of the circle. How do we tell it just that little bit? Huh? No. But you might be thinking in the right direction.
Or we might put it over 360.
Yeah, it's that same thing. Okay? That tells us the fraction of the length, but also the area. Because think about it, I'll do my pen again. As I sweep through that angle, I'm tracing out the arc length, but also covering the same area too, right? So it's the same start to the formula, just changes from circumference to area. Which is good, but also means you could get it mixed up if you're not careful. Okay? So grab your notes and let's write that in. Next time you have pizza, tell somebody you're going to have, give me a sector of pizza.
I'll just get it.
And then you'll sound cool, or you'll sound like a dork, either one.
I don't think they would understand.
But you don't?
No. I think my uncle's girlfriend was, but not my uncle.
Give me a sector of pizza. Sector 7. Doesn't that sound official? No? Sounds like a math dork. Thanks a lot. Alright, so let's define a sector first. So maybe underline area. We'll finish this and then take a break. The area of a circle bound by 2 radiuses and the intercepted arc. So maybe just to help us remember these things, this is a pizza slice. I'm going to put that on here. And just to keep it straight, I would go back up to arc length and put pizza crust. Pizza crust. Maybe that helps. We'll write the formula after the break. Alright, here's the formula. I'm going to subscript the area of a sector because Monday we're going to talk about area of a segment, or maybe later today. Excuse me, we'll see how this goes. But so we'll have area of a circle, area of a segment, area of a sector. We need to clarify which one is which. So you saw the formula, it's just theta out of 360. This time though, it's times the radius, or pi times radius squared, which is the area. So let's do what we did right up here, arrow, and explain what each thing is. That is the fraction of the total area. And then that is the area. And then we also need to do our formula, our picture. I'm going to make mine just a little bigger. And just shade that in. So here's some problems, just representative examples. We'll go put one of them in your notes, but notice it gives you in this simple one, it gives you the angle. So we're just finding the whole area of that shaded yellow. So it would just be 165 out of 360 times pi times 3. In this case, it's the radius, not the diameter, times 3 squared. Okay? Of course, you might have something where you have to calculate the area, or excuse me, the angle. But let's put one in. I was going to ask you if you want one, but it's easy enough to just add one in. What we'll do is just use the same circle, and I think from there it'll be a fast problem. So number 2, again, hopefully you wrote this yesterday, right? Okay. So for this, let's go ahead and highlight. I don't know if you guys are using highlighters, but let's highlight that sector. And we'll write down the formula. So I think I said yesterday the steps are the same. Theta out of 360 times pi times radius squared. Okay, fill out what we know. And that is 115 out of 360 times pi, and then our radius was 8 squared. And then that all goes in your calculator. And we get 64.2 if we round. I didn't put units either, so let's review this. Units what for area? Squared, yeah. Hold on. I used units there. Oh, I just didn't label them in our picture. So this is centimeters squared. Guys, sometimes students get mixed up about what that squared means, and they want to square the number. But that's not what you do, right? It just means that we're talking about a square of space, or of surface. Alright, good on those? Let's have you do, I don't know, just do a quick one. And then, I think I'd like to talk about area of a segment. What do you think? Are you ready to do that? We'll see. Let's see how this one goes. We're going to talk about Chiron. Hopefully he doesn't mind. We really should do ammo. He was the one talking about pizza. What was the one you said, 20 inch or something? How big do you want your angle to be? What was it, Kyle? Just 7?
No. No. Let's do like
Aren't you hungry?
32.
Oh.
32.
I like that.
59, okay. With a 59 degree angle. Okay. That's probably a good size. How much pizza is Kyron gonna eat?
He's hungry.
Alright, there you go. You don't necessarily need to write this down. You can just write your work down if you want. Okay, now one quick thing to mention. How much pizza is probably more likely talking about a volume of the mass of it. So it's a little bit unclear what I'm asking, but we're just talking about the area for now, okay? Because we're not going to say how thick the pizza is. So, write down our formula. So what is the radius of this? Yeah, so I gave you, when we say 20-inch pizza, we're talking about the diameter. So radius is 10. So 59 out of 360 times pi times 10 squared. 51 and a half. What are the units? Nope. Nope.
Square.
Inches squared. So square inches. Everybody make a square inch with your fingers somehow. Like, you know, I just did this a second ago for roughly a square centimeter. Can you do that with your hands for a square inch? Something like that, right? So he's gonna eat 51 of those. Suppose your bite is like 2 or 3 of those, probably. So he gets 20 bites of pizza. That seems good. 10 is the radius, so 20-inch pizza is the diameter. But in our formula, we have to use the radius for the area. So it's just half. Okay. Good? Any questions on that?
I'm hungry. You get us pizza.
Yeah, that would be fun. Alright, well, let's go ahead and do the segment. This one is not as straightforward at all, so it would be good to just throw this in here right now. The idea of it is easy. It's just where it is highlighted green there. It's just that ice cream part of the ice cream cone, kind of. Does everybody see what I mean by that? It's just that calculating it is kind of a pain because this is where we have to go back and maybe do some trig because we'll need the area of that triangle, which isn't always just given to you. But let's make sure we're clear on what this is. So a segment is just the part bounded by this edge of the circle and this chord yx. So it's shoved at the end of a sector, if you want to think of it that way. If we connect the line of the two radiuses, that's the segment. And this name has never made sense to me, ever. So I don't know how you're going to have to remember that.
What's the name?
Segment. To me, a segment is like a piece of a line, right? Not an area of a circle. So let's go define it in your notes, and then we'll probably just jump to an example of calculating its area. Because it is kind of weird. Not weird, just it's a lot of work. Sometimes. All right, guys, we have S for arc length, sector, we have segment, we have all this stuff floating around. Are you studying your notes? Okay. Please do, because it definitely will get jumbled up. Before we do the definition, let's go ahead and draw a segment. This time you're going to connect the two ends of the radiuses. And then highlight only that end part. So this is the area between the edge of the circle and the chord, which we will define more in depth soon. We have a whole section on chords. But that's what that is, that chord connecting the two radii, or radiuses. So the area between the edge of the circle and the chord connecting the two radiuses of a sector. To me, it looks like an ice cream cone in our circle. But we've been using like pizza and pizza crust, or slice and crusts. This doesn't really work for that, huh? Except for it's the part that you would have cut off, and it wouldn't be all crust because the crust kind of bends around, and this doesn't. It's got a straight bottom. Does that make sense? Except for yeah. Okay. Just pretend that it does. Okay. In terms of area of this, there is a formula, but it's not. You can't just plug numbers in. So I'm going to put C example for area because it takes a little more work. What do you think you would do to find the area? I kind of alluded to it a minute ago. And you do have the tools that you would need to calculate it probably with some review. But just looking at the shape, and I said find the area of the yellow segment, what do you think you would do? Just describe it. Don't tell me numbers or formulas or anything. I bet you have an idea.
we like find the total area and then subtract it by the sector area?
No, you're getting there. What if we found the whole area of the sector? Okay? We just wrote that, and that was easy, right? Well, what would we have to subtract to get just that part? Just the remaining yellow part. Yeah, Karen.
That one like section of the circumference or like
Well, we're dealing with area. Okay? Maybe I'll switch color with this thing first. So if we found this whole area, what is that the area of? Sector. Okay, so that's this. The area of the sector is pink. Okay, so what is being removed from the pink to leave the yellow? I'll just kind of go back and forth. What is being removed from the pink to leave the yellow? Yeah, that triangle. You see that? So it's just sector minus triangle. That's the concept. It's just that the triangle is a little bit of a pain to calculate. But it's just sector minus triangle. Okay? So go back to your example. Section and area of a segment. So highlight just segment. Again, we have 3 S words, or S things. We have segment, sector, and the S for arc length. So it's starting to get a little bit busy. Huh?
That's dumb, having S for
Yeah,
arc.
totally agree. Well, in like physics, we use S for position of a particle. Like, let's say if a car is driving down the road, we use S for its distance or position.
So S.
All right, let's get our picture on here, and then we'll put some numbers on it. But let's get the picture drawn. If you have a highlighter, this is a good place to use it. Alright, like I said, we'll put some numbers in there, but get that drawn in. We're going to call this radius of 5. So where does that go? On our picture. That's given, and let's just use centimeters so we have some units at the end. So where do we put that in our picture? Yeah, good job. There and there. Okay. So here's the big idea. We need to subscript again so that we don't get this mixed up with the area of a sector. So area subscript segment. Everybody good on what I mean by subscript? Okay. I just need more room. Okay, so this is area of the sector minus area of the triangle. That is the general idea. If I was going to give you a formula, that would be it. But I can't give you a formula for the area of a triangle. I mean, I can, but I can't give you it to use for every problem. So, here's how I would recommend doing these. Step 1 is find the area of the whole sector. Which has its own formula. What was it? You need to flip in your notes, go look at it.
Over 316 times pi radius to this square.
Awesome. Okay. Oh, I forgot to give you an angle. Let's do that. So just stick 144 degrees on there. That would be given. It's not like we're just making it up. Okay, so let's fill out our formula with 144 out of 360 pi times 5 squared. And when you're ready, go ahead and put that in your calculator. And it will look like 144 out of 360 times pi times 5 squared. So 31.4. Okay? Okay, step 2. Area of the triangle. You guys remember the formula for area of the triangle? Or of a triangle? Starts with 1/2. Or divided by 2 is in there. Okay, I'll just tell you. But you probably want to make this a note, not just an example. So triangle is 1/2 base times height. Or you could do base times height divided by 2. Either way. But what do we not have in this problem? We don't have the base or the height. That's a problem, right? Okay. So we don't have the base or height. So how the heck do we find this? Weird, right? Okay, here's what I want you to do. For this one, the triangle is sideways. So draw it. Like, zoom in on it, maybe. I'm just trying to draw it better. Sorry. That's better. So zoom in on the triangle. And all we know right now is this is 5 and this is 5, but that we do know something else. What else could you put in there? This angle, I didn't draw it as this, but it's 144, isn't it? Right? Right?
Yeah.
Why? Well, remember the measure of an arc is the same as its central angle, so we can copy it in there. If you want on your picture, you could say same as the angle, just so you know you can drop it in there. Okay. Well, that helped a little, but not a lot, because where is the height of this triangle? Like, where, if I just drew it in, where would it go? I mean, this is the base, right? So the height would go right there, right? Right down the middle. How do we find it? You guys remember the hot air balloon problem on your trig test? You can, but this one happens to be an isosceles triangle, so it's easier. So that's good news. It's a little easier than that problem at least. Okay? So that's base, this is height. Alright, zoom in again to this triangle. I need to draw it a little bigger. What kind of triangle is that? That's a right triangle. Okay? What is this angle? Now, if it's an isosceles triangle that I just cut in half, what is the measure of that angle?
It's half.
Yeah. This is half of theta, which is 72. Okay? And this is still 5, right? The hypotenuse is the radius. So it's just 5. Okay, we're almost there, I think. I mean, I know, but I hope you're seeing that you think that we are. Do you see how this line now is our height, and this line is only half of our base? Okay, but now we can at least use trig ratios to find both. So, h, and this is base over 2. Do you feel like we just jumped off a cliff a little bit? How do you find h? Knowing that's 72 and the radius is 5. By the way, the good thing about these problems is you should almost always know the radius and the angle. So the process that we do will be the same. How do you find h from that given angle?
Could we use log sign?
You can. So you could do sine of 90 over 5 equals, but then you'd have to go find this. But no, because we only have one side. So let's use trig ratios. SOHCAHTOA. Which one relates h to the 5 and the 72? So is opposite over hypotenuse. Was adjacent over hypotenuse. And TOA was opposite over adjacent. So this is cosine. Okay? So it's always going to be cosine. Cosine of 72 equals h over 5. Well, how do you solve for h? Leave h, multiply by 5. Good, good. Okay. Multiply by 5. So h is 5 cosine of 72. So our height, make sure your calculator's in in degrees, not radians. So it looks like I still am. 5 cosine of 72 is 1.55. So that's the length of this little guy right there. The height of the triangle, right? All right, base. Well, we have this length of the triangle that we'll just have to double. So let's go solve for that. Which ratio can we use for the base? Yeah. So sine of 72 equals, call it x. You don't want to put b over 2 there, but x over 5. Okay? The only thing is you have to remember to double it when you're done. Otherwise, you're only finding half the base. So x over 5. So sine of 72, this is the same thing. So 5 sine 72 equals x. Meaning we have to multiply by 5. It's the same. All right. 5 sine 72 is 4.76. This is literally combining about 5 different geometry problems into one. Area of a sector is its own kind. A cosine length, that's its own kind. Sine length, that's its own kind. Area of a triangle, that's its own kind. And then area of the segment is the fifth one. Lots to do, right? So just take your time, go slow. Make sure you calculate every part in steps so you don't miss something. I think I'm going to change this to x, but I'm just going to emphasize that it's only half the base. Okay? Just because I don't want people looking at their notes and being confused by that. And I'm going to write what I said, which was zoom in. Okay, we're just putting x there. And circling half the base. Okay. Where are we in the problem? Are you following? Area of a sector, because we have to subtract this triangle from it to get the yellow part. Why did we do all this trig? Yeah, it's the height and the base of the triangle, right? So that we can find the area of the triangle. Okay. So let's go do that. Now that we know, we have the triangle is 1/2 times. You know what? Before we do that, I don't want you to miss this. Base is double. So 4.76 times 2, which is what? What was it? 9.51, she said. Okay. So 1/2 base times height, 9.51 times height of 1.55. So the area of our triangle, we just need to go plug that in. 1/2 times 9.51 times 1.55 is 7.4. Okay, we're close to done. We have one more step. Just kind of cleaning some stuff up here. So what are we going to do to get our final result? We have one more thing to do. Yeah, take these two right there. Okay? And so all we have left is just a subtraction problem. That is step 3. So subtract triangle from sector. And we get 31.4 minus 7.4. So that is triangle. The blue one is sector. 31.4 minus 7.4 is equals 24. And this is an area, so it's centimeters squared. Phew. What do you think of that one?
I don't like it.
It's kind of beastie, huh? Like Maleficent says. Clearly the biggest part of this is finding the area of that triangle, which is basically going back and remembering the unit, last unit. It's a pretty good sweep of that stuff. Quick review on what we just did. Area of a triangle is a half times base times height, but we didn't have either of those. So we had to zoom in on our triangle, zoom in further on the half triangle, which is a right triangle, and then find the height and part of the base. Height was pretty good, it was just cosine. Half the base was sine and then double. Plug that into your area of a triangle formula, okay? Lots of steps there.